Assalamualaikum and hi. Today I would like to present to you about our case study for subject computer architecture. Firstly, I will introduce our team members. First, Intan Alicia binti Mat Ayub, 21 DIT 25 F1122. Nurul Aisyah binti Ahmad Yusni, 21 DIT 25 F1119. Syaidatul Irdina binti Syarul Niza, 21 DIT 25 F1009. Nur Tasnim Safia binti Zulkarnain, 21 DIT 25 F1383. Nur Dania Husna binti Umar, 21 DIT 25 F1176. Now, we will start the presentation with question 1.
For question 1, Security and Protection Service. An organization that handles sensitive data depends on the operating system security framework to maintain confidentiality, integrity, and availability of information. The administrator is tasked with configuring firewalls, access permissions, and intrusion detection system to secure the computing environment. First, define the concept of security and protection service in operating system. Second, describe the authentication, authorization, and encryption mechanisms that enhance system security. Third, discuss how access control policies and privilege management protect system resources from misuse. Explain the importance of implementing auditing, monitoring, and backup strategies to prevent and recover from security breaches.
The answer for question 1A is number 1. Protection refers to internal mechanism controlling resource access by users and processes, while security is the broader system of defending against external threats like virus and unauthorized access, ensuring confidentiality, integrity, and availability of data and resource. For number 2 is authorization. Access Control List (ACLS), which is list that define which users or groups can access which resources and what operation they can perform. For example, read, write, and execute. Authentication is password and pins. This is the most common method relying on secret knowledge. Or biometrics, use unique biological traits for identity verification. The third is encryption. This is how is your data hidden. You can use a symmetric encryption, which is use the same secret key for both encryption and decryption. Number 3, how access control policies work to protect system resources from misuse. You can use authentication and authorization. Policies rely on first authenticating a user's identity and then authorize their actions based on predefined permissions. Second is risk mitigation. Well-defined policies reduce security risks by limiting exposure and helping to quickly identify the source of failures or attacks. The second is how privilege management works to protect system resources from misuse. You can use a principle of least privilege. This core principle grants users the minimum permissions needed to perform their tasks, thus minimize potential damage from misuse. The second, you can use just-in-time and just-enough access. This elevated access is granted temporarily and only for the specific duration and scope required. The answer for last question is auditing, which is proactive defense and compliance. For example, quality assurance. Audits provide assurance to stakeholders, investors, and vendors about the organization's security posture. Second is monitoring, real-time threat detection. For example, accountability. Logging user activities provides a record of who accessed sensitive data, identifying unauthorized access, and reinforcing accountability. The last one is backup and recovery, post-breach resilience. For example, data restoration. Reliable, frequent backups allow organizations to restore critical data quickly after an attack or system failure, minimize and downtime.
For question 2, we were tasked with determining the best network shape for Teknova solution. We choose star topology for each floor Teknova solution. Easy to manage, all devices are connected to one central device, making it easy to add new device. Fault tolerance, failure of any one computer will not disable the entire network on that level. Stable performance, this topology provides good performance because each device has a dedicated connection to the switch. Kenapa last macam tu?
Okay je, ya Allah.
Following our decision to use a star topology, let's look at the practical implementation. Here is our proposed network diagram for floor 1, which houses the administration and human resources department. As you can see, this diagram perfectly illustrates the star topology we just discussed. At the center, we have a central network device. The diagram notes a hub or switch, but based on our need for stable performance, we will be using a switch. This is our 6-port switch. Connected to this switch are the 5 laptops and 1 printer shared by the staff. This includes 5 laptops for the staff members and 1 shared network printer. This setup is clean and efficient. Each of the 6 devices gets its own dedicated port on the switch. This means if one laptop has a cable problem, it won't affect anyone else in the department. Now, let's move up to floor 2, which is for the software development and R&D department. You will see we are using the exact same star topology strategy here, but the scale is different because this department are large and have more technical needs. We have planned for more devices. At the center, we have a large 16-port switch. Again, we are specifically using a switch for maximum performance, not a hub. Looking at the device, you will notice they are more specialized. We have 10 high-spec desktop. These are more powerful workstations needed by developers and research for coding, running tests, and handling large data. And importantly, a dedicated server. This is critical for the R&D team, likely for version control, a local testing environment, or data storage. In total, we have 30 devices connected to the 16-port switch. This is excellent planning because it leaves us with 3 spare spots for future expansion, whether they hire new developers or add another specialized device. Just like on floor 1, this setup ensures that if one developer's workstation goes offline, it doesn't crash the server or affect anyone else on the network. Finally, let's look at our plan for floor 3, which handle customer support and sales. Once again, we are implementing at the same reliable and easy to manage star topology. This setup is very straightforward. At the center, we have an 8-port switch. As with the other floor, we are choosing a switch to ensure stable performance for every user. Connected to this switch, we have 5 desktop computers for the staff in the support and sales team. This setup is perfect for this department. It provides a reliable connection for every team member, which is critical when they are dealing with customers. By using an 8-port switch for 5 devices, we also have 3 spare ports available, making it very easy to add new workstations as the sales or support team grow. Habis.
Question 2. Describe instruction set, machine language and assembly language. Instruction set. The instruction specifically developed to accompany that particular hardware as a package. Instructions are categorized according to basic operation performed. The complete list of instructions is known as the instruction set. These instructions are actually listed as reference instruction groups, whereby each group in the list may have several instructions with related functions such as move, move A and move Q. For machine language or machine code is a low-level programming language consisting entirely of binary digits, which is 1 and 0, that a computer's central processing unit can execute directly. For assembly language, a low-level programming language with a direct correlation to a computer's machine code instruction. It uses mnemonic codes and symbols to represent these instructions, making them more human-readable than raw binary or hexadecimal code.
Okay, today I will explain about the groups of instruction in a microprocessor. There are three main groups: arithmetic instruction, data transfer or movement instruction, and logical instruction. First, the arithmetic instruction is used to perform mathematical operations such as addition and subtraction. For example, the instruction add B D0 D1 before the operation D0 $00002222 and D1 $00004444. After the operation, D1 becomes $00004466. This means the 4 bits value in the D0 is added to the 8-bit value in D1, and the result is stored in D1. Second, the data transfer or movement instruction is used to move data from one place to another. For example, from one register to another. The example here is move B D0 D1. Before D1, $00200500 and D0 is $00002222. After D1, $00200522. This shows that the data from D0 is copied to D1. Lastly, the logical instruction is used to perform logical operations such as AND or NOT. For example, NB hashtag $3E D1. Before D1, $1234567 After D1, $1234564. This means the AND operation compresses the bits and stores the result in D1. In conclusion, these are three groups of instruction: arithmetic, data transfer, and logical. Are very important because they allow the microprocessor to calculate, move, and make decisions in a program. Thank you.
Question 2C. Find D1 value after instruction execution. Question first. Move.b D0 into D1. Move.b is .byte. .byte we need to move two numbers from the back into D1, which is 15 in D0, move into 55 D1. So after the execution, D0 will be the same as before, and D1 are going to be 00000015. For the second question is add.b 25 into D1, which is D1 is 00000055. We need to do addition with 25, which is 55 plus 25 equals to 80. So we need to put 80 into D1. So it will become 00000080. Next, for the third question is sub.b D0 into D1, which is sub is subtraction. So we need to subtract D1 and D0. So because of this is dot B, we need to subtract only two numbers from the back, which is 5, 5 and 1, 5. 5 minus 5 is 0, 5 minus 1 is 4. So after the execution, we will get D0 same as before and D1 equals to 0, 0, 0, 0, 0, 0, 4, 0. After that, the fourth question is mulu.w D0 into D1. Mulu means multiplication, .w is dot words. Words, we need to move 4 number from the back. As for this question, we need to multiplication D0 and D1. But to make it easier, we will change this hexadecimal number into decimal number because it is easier to do a multiplication in decimal terms. After we change the number into decimal, we will do the basic multiplication, which is we got D0 21 decimal and D1 is 85 decimal. We multiply these two numbers, which is 25 multiplied 85, we got 1785. After we got the answer, we need to change it back into hexadecimal and we get 06F9 hexadecimal. For the answer of this question, we will get D1 equals to 000006F9. Next, for the fifth question is divu.w hashtag $0005 into D1. So for this question, divu means divisions and as usual, .w is dot words and we need to divide D1 with 0005. As for this question, this is same with the fourth question. We need to change it into decimal numbering. As for this number, 0005 hexadecimal equals to 5 decimal and 0055 hexadecimal equals to 85 decimal. So since we get this in decimal, we need to divide 85 with 5. So we will get 17 decimal. So 17, we need to change it back to hexadecimal, which is we got 0011. So in the answer, we will get D1 equals to 00000011. Next, the instruction is n.b hashtag $3c into D1. For this question, we need to use truth table of the logic gates. Okay. For this question, we have 3c hexadecimal. We need to change it into binary because we need to look at the truth table of the logic gates, which is it's only consists of 0 and 1. So after we change it into binary number, we got 0011 10010. As for the 55 hexadecimal, we got 0101 and 0101. After that, we need to compare with the truth tables of the logic gates, which is n is simple, like 00 equals to 0, 01 equals to 0, 10 equals to 0, 11 only consists 1. As for this question, we need to compare 3c and 55. We need to compare c hexadecimal with 5 hexadecimal, which is c hexadecimal is 10010 and 5 hexadecimal is 0101. Okay, after we compare, we got 0 and 1, which is 0, 1 and 0 is 0, 0 and 1 is 0, 0 is 0. So we got 0. After that, we need to compare 3 and 5, which is 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, 0 and 0 is 0. So we only have 1. So the answer will be D1 equals to 00000010. Next, we have R.B D0 into D1. So we need to use the same ways as the previous question, which is we need to change it into binary number. So we need to change 55 into binary and 15 into binary. So 5 equals to 0101, 5 also 0101, and 1 equals to 0001. So after compare, for all logic gates, the truth table is quite different, which is 00 equals to 0, 01 equals to 1, 10 equals to 1, 11 equals to 1. Okay, so we need to compare 5 and 5. We got 1 equals to 1, 0 equals to 0, 1 equals to 1, 0 equals to 0, which is we got 5. So next, 5 and 1, we need to compare, which is 1 equals to 1, 0 equals to 0, 10 equals to 1, 0 equals to 0. So we still got 5. So the answer will be D1 equals to 00000055. Lastly, we have exclusive OR.B hashtag $25 into D1. So exclusive OR, we need to use the same way as the previous question, which is change it into a binary number to make it easier. So for exclusive or truth table, we have 0, 0 equals to 0, 1, 0 equals to 1, 0, 1 equals to 1, 1, 1 equals to 0. Okay, after we change into binary number, 5 we got 0, 1, 0, 1, 2 we got 0, 0, 1, 0. So we need to compare with 5, 5. So 5, 5 is 0, 1, 0, 1. Let's compare 5 and 5. 1, 1 equals to 0, 0, 0 equals to 0, 1, 1 equals to 0, 0, 0 also equals to 0. So we have 0 on this side. So the next side is 2 compared with 5, which is 0, 1 equals to 1, 1, 0 equals to 1, 0, 1 equals to 1, 0, 0 equals to 0. So the answer is 0, 1, 1, 1. So we have the number of 7. As for this question, the answer will be D1 equals to 0, 0, 0, 0, 0, 0, 7, 0.
Short conclusion and analysis. The case study successfully analyzed the problem of discussing and present applied knowledge of computer architecture concepts including operating system, networks, and assembly language through a case study by employing an integrated system approach. The assembly language code provided the necessary low-level control to make them more human-readable by directly interacting with the instruction set architecture. This hardware-level efficiency was governed and secured by the operating system. Concurrently, the computer network structure with star topology provided a scalable and secure communication backbone for the system's operation. The final judgment is that the architectural choices represent a successful trend of prioritizing continuous facility while maintaining acceptable standards for scalability.